Hey Sam, I have your most recent quiz here. I did reset the assignment for you, so after we go through this quiz or this video, you can do the assignment first. You can watch this video first and then do the quiz after you've got the assignment completed again. So this one's asking for a statement that best describes the accuracy of her congruency statement. So when we talk about congruency, when we state that two figures are congruent, we need to make sure that we are always matching the letters that are in the corresponding positions. And so it says that Charisse reflects the figure RSUT over the y-axis, then rotates the reflected figure 180 degrees about the origin, resulting in figure A. So it went over here first. I'm just going to kind of draw this picture in here. It went here, here, 1, 2, 3, 1, 2, 3, and then all the way up and over. So this is where it went first. And then there was a rotation 180 degrees about the origin. And so we use letters sometimes that also have apostrophes in them when we talk about transformations. And so this one, I'm going to call it R prime, S prime, T prime, U prime, because it is after a transformation. And then I'm going to talk about the rotation again. So when we rotate this figure 180 degrees about the origin, then you can see that R prime ends up, let's see, U prime, this is going to be R, I'm going to call it double prime now because it's moved twice, U double prime, T double prime, and S double prime. And so S is matched with Y, yeah, Z is matched with R, yep, okay, so RSUT has to match up and go in that same order. So you can see how R became R prime, became R double prime, which they've labeled Z. So R does match with Z, those both come first. And then they have S next, that's way up here. S matched with S prime, which matched with S double prime, which they have paired there with letter Y, so you can see it second, and now it just follows itself clockwise or counterclockwise. This one went R, S, U, T, so this one goes Z, Y, W, X. So the pieces, the letters themselves are in the same order. The corresponding parts should be in the exact same spot, and so that's what we see here. So that was an accurate statement. We'll change the direction, and it changes the direction. Yeah, the reflection changes the direction that you go around the shape. So if you were going clockwise around it here, you would go counterclockwise around it there because it was reflected. Rotations themselves keep the order the same, but again, it was the reflection that changed the direction of the vertices. Another statement similar to that last one, Jason states ABC is congruent to RST. Kelly states ABC is congruent to TSR, which best describes the accuracy. So you can see right away, if we're starting in this lower left-hand corner when we name the triangle, we have to start in the lower left-hand corner when we name the congruent triangle. So ABC, it goes clockwise around the shape. RST also has to go clockwise around the shape. So Jason's definitely correct, but now let's look at what kind of transformation did we have. It doesn't actually say. What's interesting about a triangle like this is we could have a reflection here and maybe we can't see it because the triangle itself is symmetric. So let's just read these. Jason's statement is correct. RSG is the same orientation, shape, and size. So that's not wrong. Both statements could be correct. RST could be the result of two translations of ABC. Two translations, like sliding it down and then sliding it to the left. TSR could be the result of a rotation and a translation of ABC. A rotation is going to, that would actually change the order. So that one's not right. Both statements could be correct. RST could be the result of two translations. Yep, so we could, if it slides down and then it slides to the left. TSR could be the result of a reflection. Yeah, so that reflection, if I take that triangle ABC and I reflect it like over the y-axis, let me show you what would happen. Let me clear that off. If I reflect this over the y-axis, I would have A here, A prime, I'm going to call it. This would be C prime, and this would be B prime. And so now when you slide it down, you can see that A actually matches with T, which is how Kelly has stated it. So A prime and T would go together, C prime and R would go together, and that would leave S and B together. So A, then B, then C, that would actually go in the other order, T, then S, then R. So while your first statement, the one you chose isn't wrong, but also Kelly could be correct if there had been a reflection. Remember that reflection is going to change the order in which things are given. So it goes, notice how it goes counterclockwise versus clockwise. That was a tricky one. Which sequence of transformations produces A prime, B prime, C prime from ABC? So we're starting with ABC. And on these, honestly, this is what I tell students. Try them all. Try them all until you find the one that actually works. So I'm going to work through that first one, the translation up 3. Every point's moving up 3. 1, 2, 3. And then 1, 2, 3. And 1, 2, 3. So here's my triangle after the translation. And then it says a 90-degree counterclockwise rotation about the origin. And so this is where I tell students we need to kind of remember some of our rules for what happens with ordered pairs when we rotate about the origin. So when it is a 90-degree counterclockwise rotation, the X and Y ordered pairs, the Y becomes the X and changes sign, and the X becomes the Y, and it doesn't change sign. So check this out. This is B prime, this is A prime, this is C prime. I also realize it's in the middle of the transformation. When we actually rotate it now, we are going to then name it A prime, B prime, C prime. So let me show you what these ordered pairs are in my red triangle. 4, -1 is B prime. A is 3, 2. And C is 1, 1. So according to my rule, I need to switch the ordered pairs, I need to switch the numbers, and the Y is going to become negative. So that means -2, +3, 1, 4, and -1, 1. So that's what happens to all of those ordered pairs. So now I'm just going to verify. -2, 3, there's A prime. 1, 4, there's B prime, and -1, 1, there's C prime. I don't know if I would hope the lesson would share this information with you about transformations and what actually happens to the ordered pairs. I'd also hope that you'd written some of that down, because that stuff is, I don't even have all of that memorized. So write what I have down in that blue cloud somewhere. Hopefully you have like a math notebook or something, you can put that in there. That's 90-degree counterclockwise rotation. All right, let's keep going. 4. Harley graphs a polygon that's located entirely inside quadrant 1. He rotates figure clockwise 90 degrees about the origin and then reflects. This is, you just draw yourself a little shape, right? Oh, that's looks like a piece of cheese. Let me try again. I'm trying to make it a polygon. That's not like regular. Oh, that's fun. He rotates the figure 90 degrees clockwise about the origin and then reflects the rotated figure over the x-axis. So if I'm going to rotate 90 degrees clockwise, I'm going to end up down here, right? Think about a clock. That's the way they go. And if it's only 90 degrees, that's a quarter of a turn. So right now I'm down in quadrant 4. This is 1, 2, 3, and 4. Quadrants are named starting in the upper right-hand corner, and they go counterclockwise around, and typically we use Roman numerals. So there's all that information. And then reflects the rotated figure over the x-axis. So if our figure is now down in here, and I reflect over the x, it's going to put me back here. Okay, so now I'm back in quadrant 1. Now it says You translate the resulting figure 3 units to the left. So I'm going to go 3 units this way, and then I'm going to go 3 units up, which best describes the location of the final image. So I can't actually say it's in quadrant 2 because this 3 units left might put some of it in quadrant 2. It might put none of it in quadrant 2. I don't know how far left. All it says is that I was entirely inside the first quadrant. Well, what if it was butted right up here somewhere like this? And if it's butted up there and I go 3 that way, then it's partly in the quadrant 2, but not all of it. So the only thing you can say definitively is that it's above the x-axis. That's the only thing we know for sure, because it could all the way be in quadrant 2. It could still all the way be in quadrant 1, and it could be in both, right? It could be actually on the y-axis. The shape could have been somewhere here. We don't know how far away it was from the y-axis to start, so we can't say that it's in quadrant 2. All right, which sequence excuse me, of transformations produces r prime s prime t prime from RST? A translation 2 units right. So that's going to go 1, 2, 1, 2, 1, 2. Here, here, and here. And then it's a reflection over the x. So when we reflect over the x-axis, the points are the same distance above and below. So r prime was on it. It's still going to be on it. We've got s all the way up here. It's 1, 2, 3 units away. So it's 1, 2, 3 units away. Same with t to t prime. It's 1 unit above. So now it's 1 unit below. And that is reflection. Let me see I'm just going to look at the one that you picked and see if I can get what that one would be. So 90 degrees counterclockwise rotation. So we just shared that if those ordered pairs are x, y, the y is going to move into the x spot and change signs, and the x moves into the y spot. So the first thing I'm going to do is name these ordered pairs, r, s, and t. R is at 0, 0. S is at -2, 3. And t is at -3, 1. So when I rotate that 90 degrees counterclockwise, that's actually going to stay at 0, 0. This is going to become my -3, right? The y moves to the front and becomes negative, and the x goes to the back. The y moves to the front, becomes negative, the x moves to the back. And then it says a translation 2 units right. So let me plot this. This is like in the middle, this is like right here, before the and then part. So we're at 0, 0, we're at -3, -2, and we're at -1, -3. So I'm here. And if I just move this 2 units right, I end up here, here, that one's right, but none of the other points are right. It would look like this. And so you can see how that doesn't match that black one in the background. Really with these, you kind of have to try them all, and you have to figure out which one works and which ones don't work. Rotated 180 degrees using the origin as the center, which sequence of transformations will produce the same result? Reflection over the x, reflection over the y. Yeah, so that actually it's a little bit of a trick, kind of. If we look at the one that you chose, a translation up 4 units, 1, 2, 3, 4, oops, my pen, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, it would look like this. If I reflect that over the y, which is the answer you picked, I would end up here, here, and here, like that. But a 180 degree rotation about the origin is the same as reflect over the x and then over the y, or you can say it vice versa, reflect over the y and then reflect over the x. So that's something maybe you can remember to be helpful. Oh, and now we get to do one without even a graph. Okay, so when I teach this to my students, I teach a lot about ordered pairs, so we actually can figure out what the ordered pairs are and not even have to worry about like actually graphing it. So we're given vertices, then we're given the image, And we're supposed to figure out, oh, hang on.
This is Monk. Please come to the office. Monk, please come to the office.
So we're going to see which of these actually work. A reflection over the x, and then a reflection over the y. So when you reflect, I don't know, maybe it's helpful to write some of this stuff down. When you reflect over the x, you start with an ordered pair like this. The x stays the same and the y changes signs. When you reflect over the y, your ordered pair, your x changes and your y stays the same. Okay, that's helpful for reflections. So if I reflect over the x and then over the y, the first thing I'm noticing is that the ordered pairs don't ever switch spots, they just change signs. So -2, -1 now becomes -1, -2. That can't be right, because whether I do y first or x first, x and y stay where they are, they just change signs. So it's not the first one. Reflection over the y-axis, and then a 90 degrees clockwise rotation. So the 90 degrees clockwise rotation, I know I shared about counterclockwise earlier, that is x and y become y and then a negative x, or the opposite. I guess I should say the opposite. When it is negative, it'll become positive. So reflection over the y would keep these ordered pairs like this. So the x is going to change signs and the y is going to stay the same. The x is going to change signs and the y stays the same, and at 0, 0, nothing happens there. Now if I'm going to do a 90 degrees clockwise rotation, it looks like they switch spots, and then when the x moves to the back, it becomes negative. So they switch spots, and when the x, so switch them spots, okay, look, switch spots, and then the 2 is going to become negative when it moves to the back. Switch them spots, and the 3 becomes negative in the back. Switch them spots, the 1 becomes negative in the back, and then obviously 0, 0, nothing changes there. And you had it the other way around. So let's check out what happens when you go the other way around. If I reflect or do a rotation first, they're going to switch spots, and the x is going to be negative in the back. So let me undo all of that. I'm going to rewrite the answer choice you picked so we can see where we went wrong. 90 degrees clockwise rotation, so that's this one. So the x and y change spots, and when the y moves to the back, it becomes the opposite sign. Or when the x moves to the back, it becomes the opposite sign. So a 2 up in front, and then a positive 3, a 3 up in front, and a positive 1, and then 0, 0. Now when we have a reflection over the y stays the same and the x changes signs. So if the y stays the same, I should have a positive 2, and I don't. I have a negative 2. So that one didn't work. Okay, that's a lot. I would definitely try to go through that assignment again. If you need some other supports, I can help you with ordered pairs. I'm not 100% sure what all they show you in that lesson, but I would write down some stuff, especially if they're talking about what happens, what's the rule when you do these transformations, like what happens to the x and the y coordinates, and then reach out if you need any more help.